Hi everyone, thanks for watching my YouTube contents. I'm Sangwoo Kim. In this video, I would like to share how to get confusion metrics based on binary logistic regression analysis. In the previous video, I showed you how to do logistic regression analysis in Excel and R. Once you get estimates and related statistics, probably you want to evaluate statistical models' performance. One of the popular ways for evaluation is to get confusion metrics. According to Wikipedia, there are many various measurements to evaluate classification models' performance, such as sensitivity and specificity. In Wikipedia, actual conditions are set as rows and predicted conditions are set as columns. I recommend you to visit this website for further information. In our program, you need some commands to get confusion metrics. After you run logistic regression analysis by using GRM function, you need to generate predicted values by using threshold predicted variable by using threshold value. In this video, let me use 0.4 as threshold value. So if predicted probability is less than 0.4, then we allocate predicted value as 0. If not, predicted value as 1. You can get confusion metrics from Caret library. One thing you need to be careful when you use confusion metrics function is to specify predicted variable and reference variable like this. Then you can get these outputs. As you can see, our outputs as confusion metrics, rows as predicted prediction, and columns as reference, which is different from Wiki's structure. Again, in Wikipedia, rows for actual conditions and columns for predicted conditions. Let me show you how to get these confusion metrics based on our output. Right? Let's set threshold as 0.4 and predicted value. If this probability is less than 0.4, then let's allocate it as 0. If not, let's allocate it as 1. In order to make this frequency table, let me combine predicted value and actual value. Right. Then we can use count if function, range from column G, fix the cell, and comma, and criteria as the combination of predicted value, fix column, put and symbol, and columns, and fix. Okay. Then we can apply this cell formula for other cells. Right. There are 25 samples. Then let's get cell probability here over sum of 2 by 2 cells. And let's get marginal probability. Right. Then the accuracy can be calculated by using 10 plus 9 diagonal cells and over total frequency. Right. And 95% confidence interval, the low bound and upper bound, we can use this formula. So to make this video short, I already made formula in Excel. We need to give x and n value. So n is total frequency, and x is actually off diagonal elements, 2 plus 4, right? And then for upper bound, we can use this formula. This is from this one. Okay. Then no information rates is from max of column marginal probability, right? So we want to test whether this accuracy is higher than no information rate. So the p-value can be calculated by 1 minus binomial distribution and minus x minus 1 comma 25. Actually 25 is from this one, and comma no information rate probability comma true, right? So same as this one. So we can reject null hypothesis. It means that accuracy 0.76 is significantly higher than no information rate, right? Then let's move on to calculate kappa index. Kappa index can be calculated by using this formula. So P0 is proportion of observed agreement. So 10 plus 9 over total frequency, and expected probability is the marginal sum, marginal probability, first row marginal probability times first column marginal probability plus second one. Then kappa index can be calculated by P0 minus PE over 1 minus PE, right? And same as this one. So kappa index 0.52, this one. So according to this website, 0.5 kappa index means that moderate strength of agreement, right? Let's move on to calculate McNemar's test p-value. Yep. So this is null hypothesis, and chi-square statistic can calculate by B minus C minus 1 and squared over B plus C, and McNemar's p-value can be calculated by 1 minus chi-square distribution and chi-square value comma degrees of freedom. It is 2 by 2, so it means that 2 minus 1 times 2 minus 1 comma true, right? So it means that we cannot reject null hypothesis. So it means that this one probability for this cell and probability for this cell, we cannot statistically it is the same, right? Right. So this is main parts for confusion matrix. So let's get sensitivity. So I already put a simple formula here. So sensitivity is true positive, this one, over total positive. Okay, and specificity can be calculated by true negative over negative column here, and positive predicted value, same as precision, can be calculated by true positive over predicted positive. So sum of this one. Okay, and negative predicted value first negative over negative P, this one, right? Yeah, negative predicted. And prevalence is positive sum of this one, positive, this one, and over sum over okay, and detection rate true positive over sum of over cells, and detection prevalence sum of predicted positive over sum of all cells. Right. And the last one, balanced accuracy, can be calculated by sensitivity plus specificity divided by 2. Right. Same as our output. So based on this confusion matrix, we can evaluate your model's performance, as I mentioned. So higher accuracy, the reference could be 0.5, because if we set it as 10, 10, 10, 10, as you can see, accuracy is 0.5, and sensitivity and specificity is also 0.5. It means that the model is not good to classify observations based on logistic model. So again, once you have a higher accuracy and also higher sensitivity and specificity, so it means that your model's performance is good compared to random model. I hope it was useful to understand how to calculate confusion matrix for 2x2 type based on binary logistic regression analysis. Please click like and subscribe if it was useful for you. Thank you.